Hello, my notable Algebra 3 students. We are ready for another exciting online trip. Today, we will use the summation notation, often known as sigma notation. This is in Chapter 13, Section 4 in our ebook. The sum of the terms of a sequence is called a series. When you add up the terms of a sequence, it's called a series. The nth partial sum of a series is the sum of a finite number of consecutive terms, beginning with the first term. S sub n represents the partial sum. If we have the series 3 plus 7 plus 11 plus 15 plus 19, see this series because we have the sum we're adding. The sum of the first three terms, S sub 3, first three terms, 3, 7, 11, will be 21, the sum of the first three terms. That's the nth partial sum. Then we have a special notation, the summation notation, which also uses, we use the Greek capital letter sigma to represent a summation, which means we're going to be adding something. Represents a sum. The Greek capital letter sigma. And we have a special representation here. Let's look at an example. Here we have the sum of the first five terms of a series. You see the nth term is 2k. So the k is called the index of summation. You can use any variable you like for this index of summation. Our book is using k. Some other books might use I, but you can use any letter to represent the index of summation. The 1 is a lower limit of summation. That's the smallest number that you're going to start with. You're going to end up with an upper limit of summation. It's the largest number that you're going to go to, and it's going to be an integer. See, the domain is the set of what? Positive integers. This 2k is the explicit formula for the kth term of the series. So let's look at an example of this. Here we're going to solve this. We're going to find the sum of the first five terms. The sum of the first five terms. So see, the k will be 1, 2, 3, 4, 5. The smallest k is 1. We go up to the largest k, which is 5. The lower limit 1, the upper limit 5. So wherever k is, I'm going to put it in, substitute for this k. So you see, this will be 2 times 1. See, k was 1, plus 2 times 2, k was 2, plus 2 times 3, k was 3, plus 2 times 4, the k was what? 4, plus 2 times 5, you see the k was what? A 5 here. And 2 times 1, 2, 2 times 2, 4, 2 times, and I left off my time sign here, 2 times 3 is what? 6, then 2 times 4, 8, and 2 times 5, 10. When we add all of this up, we're going to get 30. So the sum of the first five terms of this series is equal to what? 30. Let's look at another example. We want to find the sum, or the lower limit is 3 and the upper limit is 6. And the explicit formula is k squared. And the k will be 3, 4, 5, 6. See the lower limit and the upper limit. Lower limit 3, upper limit 6. Integers 3, 4, 5, 6. So wherever I see k, the first integer that I'm going to use is a 3. So it's going to be 3 squared plus 4 squared plus 5 squared plus 6 squared. Well, 3 squared will give us 9, 4 squared 16, 5 squared 25, 6 squared 36. When we add all of these up, we're going to get 86. So here, let me see if I can get all of this right here. Here we have the sum of this series will give us 86, where the lower limit again was 3 and the upper limit was 6. Let's look at a third example. We'd like to find the sum where the lower limit is 8 and the upper limit is 10. So the K will be 8, 9, 10. And this K only refers to the number that is directly beside, which is the 2. And it's going to be 6 times 2 to the 8th, you see 8, plus 6 times 2 to the 9th, plus 6 times 2 to the 10th, 2 to the 8th, 256, 2 to the 9th, 512, 2 to the 10th, 1024, then 6 times 256, 1536, 6 times 512, 3072, 6 times 1024, 6,144. When we add all of those up, we get 10,752. And again, when you are watching this video, always remember to stop, rewind, review. Stop, rewind, review. My love going out to you.